Hey guys, we're starting chapter 2, section 3 today. We're going to be talking a lot about product rule and quotient rule. You guessed it. This stuff, we got a couple tricks to help you remember it, but this is definitely something you'll be using a lot in calculus. So let's dive right in. First thing we're looking at today, the product rule. Okay. What it's saying is when you take the derivative of two functions being multiplied together, right, your function 1, your function 2, what you have is your first function multiplied by the derivative of your second function, right? And then your first function plus your first function multiplied, or the derivative of your first function multiplied by just your second function. Okay. We have a little something, a little way to help remember this, but you actually got to switch these. It doesn't matter, right? It's multiplication type deal. But what we write is 1d2 plus 2d1. All right? And that's supposed to say, like, you're doing the first function multiplied by the derivative of the second one, and then the second one multiplied by the derivative of the first one. Okay? So that helps you remember. The quotient rule one, to me, is a little easier with the low d type thing, but yeah, so that's the product rule. Okay, so moving on to examples. That's pretty much all we got today is examples. So, first one. First thing you got to do is identify your two functions, right? We got, let's just say, our f, our d. So when we take the derivative of our whole function, we're going to have x squared plus 1, 3x squared plus x cubed plus 3 times 2x. Okay, notice we have the first one multiplied by the derivative of the second one, and then the second one multiplied by the derivative of the first one. Okay, then from here, it's just simplifying it all out. Okay, something we should all be good at by now. Okay, keep going. Your final result should be this guy right here. Okay? Really, remember, just like I said, it's all about setting up these problems, and the arithmetic math stuff that goes with it really isn't that hard. We're just adding and subtracting. All right, hopping on down to 2, we got something a little bit bigger down there. So when we write it out, right, identify, we got our f, we got our d. So when we take the derivative, we got x4 minus 3, 6x plus 4, plus 3x squared plus 4 minus 1, 4x cubed. Okay. Another good thing you guys could be doing with these lectures is when we have days like where it's all these example problems, stop before we start the problem. Or if you have trouble setting it up, watch me set it up and then pause the video, try to work it out on your own, and then watch me solve it afterwards. Okay? So we're going to keep going with this one, expand it out. It's going to be much longer. Okay, 6x to the 5th plus 4x to the 4th plus 12x to the 5th, 16x to the 4th, minus 4x to the 3rd, minus 18x, minus 12. Okay, so we should have something like that. We're going to combine like terms for our final answer. 18x to the 5th, plus 20x to the 4th, 12. Okay, this big long thing, that's your final answer. That's simplified. Okay, now we're on to 3. 3, notice it's squared, so it's kind of like having the same function twice, right? We could write that as 2x squared minus 1, 2x squared minus 1, right? So you have two functions, they're just the same thing. So when we take the derivative, slide this guy up. So when we take the derivative, looks like this. Minus 1 times 4x plus 2x squared minus 1 times 4x, right? It looks the same because they're doing the same thing to both functions and they're both the same function. So from here we just keep expanding out. And then you finish with 16x squared minus 8x. You could also do something a little different. If you notice from this line right here, once you take the derivative, you could pull each of those things out, right? You could have a 2 times x squared minus 1 4x, right? We're just pulling that 2 out because we have the same thing. And then from here, from here, right? You still finish with the same thing. Okay, 2 little ways of looking at it, whatever works for you. All right, moving on down to 4. So for 4, okay, we got more trig stuff. All right, we have to think about this as 2 functions, right? We have our f and our d, like that x and that sign. So when we do the derivative, we got the first one times the derivative of the second one plus the second one times the derivative of the first one. So this is your final answer. There is no more simplification. X times cosine of x plus sine of x. Alrighty. Moving on to 5. Let's change up the color. All right, number 5. All right, so identifying our 2 functions. We got our 2 functions. Now we're going to take the derivative. 1d2, 2d1. It's going to equal x to the 1/3 times 1/3 x to the negative 2/3 plus x to the 1/3 minus 2 times 1/2 x. All right, and you guys, the way I took our 2 functions at the beginning and switched them into their fraction form, right? So this is the same thing as x to the 1/2, and this is x to the 1/3 minus 2. Right, I got rid of those radicals and put them in an exponent form. Okay, so let's keep moving. We keep simplifying this down. 1/3 x to the negative 1/6 plus 1/2 x to the negative 1/6 minus x to the negative 1/2 equals 5/6. We're combining like terms. X to the negative 1/6 minus x to the negative 1/2. That should give you minus 1/x to the 1/2. Okay. So you could stop right there, but we could actually keep simplifying it. We could get rid of that minus sign. From here, we can multiply. We need to get a common denominator. So in order to get a common denominator, we're multiplying, our denominators on both sides. So when you do that, you should get 5x to the 1/2 minus 6x to the 1/6 on top. And then you'll end up with your 6x to the 2/3 on the bottom. Okay. Now we have to combine our exponents, our so we can pull out our um, our common factor. So let's go up here. Your end result should be 5x to the 1/3 minus 6 all over 6x to the 1/2. Okay. All right, moving on to 6. Let's head on down to 6. Okay, back to some trig functions. All right, so we have to notice that our product rule is going to take place over these two parts, right? This is a third one that's outside that's being added on. Okay, so when we take the derivative of y, notice, look, they're using y, so we have to write it as y prime. Okay, we're only worried about those first two, and then we're going to take the derivative of the last one and add it on. So we're only doing the product rule for those. Okay, so we should get 2x minus sine x plus cosine of x times 2 minus 2 cosine of x. Okay. Now we from here we can just simplify, right? Our cosines cancel out, and we're going to be left with a negative 2x sine of x. All right, and because they only asked for the first derivative, we're going to stop right there. If we had to take the derivative again, of it again, then we would use these two functions, but we're going to leave it like that. Okay. All right, so that's it for the product rule examples. We're going to move on to the quotient rule, okay? So this one, a little bit more complicated, but still not too bad. All right, so first let's just look at it. We have the derivative. We're looking right here. We have the derivative of f of x over g of x in terms of x. So what we write is we say this top one is high, right? High side, low side. So what we write for this, the same way as we wrote low, d high, d low, and all that, we write it like low, d high, and then high, d low, and then this is just low times low. Low, d high, high, d low. Okay, that's a big way people remember this. So it's your bottom term times the derivative of your top term minus your top term times the derivative of your bottom term all over your bottom term squared. Okay, if we just write it out like this, they write it low d high, high d low, low times low. Okay, that's how people remember it. So let's hop into some examples, see it in action. All right, so we have our high function and our low function. Right, we have our high, we got our low. So we're gonna look, we're gonna set this guy up. Our g of x is gonna equal x squared plus 1 times 5 minus 5x minus 2, 2x. Okay, all over our low times our low, which is going to be x squared plus 1 squared. Okay, if you look at these two, you can simplify these real quick. Get your negative 10x squared plus 4x. Over here you can get your 5x squared plus 5. Okay, so when we add them together in the next line, we should have, we should have negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. All right? And that's your final answer. No need to simplify it any more than that. Just expanding out the denominator is not going to make it look cleaner. All right, moving on to 8. So we got our high, we got our low. So we're taking the derivative. All right, it's going to equal our x minus 5, 2x minus 2, minus x squared minus 2x plus 3, times 1 all over our x minus 5 squared. Okay, simplify that again. 2x squared minus 12x plus 10 minus x squared plus 2x minus 3 all over our x minus 5 squared. One final simplification. All over our x minus 5 squared. All right, that should be your final answer. X squared minus 10x plus 7 all over x minus 5 squared. All right, moving on to 9. Got a couple more of these. Okay, looking at 9. We have cosine of x over x. So we got our high, we got our low. So we're going to have our f prime of x equals x times negative sine of x minus cosine of x times 1 all over x squared. All right, this one doesn't take a whole lot of simplification. There's not much more you can do with it. So your answer is negative x sine of x minus cosine of x all over x squared. All right, and that's it for that one. Some of these can be real quick and simple. All right. 10. Looking at 10. Also remember x cubed. That's the same thing as our x to the 1/3. All right, so we have our high and our low. So now we're taking the derivative. Don't want to make that negative. F prime of x equals to be x to the 1/3 times 1 minus x minus 2 1/3 x to the 2/3 negative 2/3. Okay. Next line as we go. Simplifying. Oops, actually, look what I forgot. I forgot to put this all over your x to the 1/3 squared. All right, so next line now. X to the 1/3 minus 1/3 x to the 1/3 plus 2/3 x to the negative 2/3 all over x to the 2/3. Let's try to squeeze another line in here. We got 2/3 x to the 1/3 plus x to the negative 2/3 all over x to the 2/3. Okay, we're going to come back up here now. Almost done. We're going to simplify this a little bit more. We end up with 2/3 out front. And we get x to 1/3 over 1 plus 1 to the x to 2/3. That's 1 over x to 2/3. Okay, and we're going to multiply the top and bottom by that x times x to the 2/3. So you're going to get 2/3 x plus 1 over x to the 2/3 times 1 over x to the 2/3. And then you're going to get 2 times x plus 1 over 3 times x to the 4/3. Oops. X to the 4/3. That is your final answer. Okie dokie. Moving to 11, they want us to rewrite each function and find the derivative. So rewrite each function. So they want us to simplify it before we do anything, before we get any crazier. So the way I see it is, think about how we did our quotient rule stuff. We want to simplify this. You might not want to simplify it the most you can, but you want to simplify it so you can manipulate it the fastest. So what I'm seeing here, I'm seeing that this is equal to pull an x out. Just pull one x out. You can pull two, but if you just pull one x, you can get 2x squared plus 3x all over x. Now look, you can simplify, crossing those x's out. So now you're just taking the derivative. So when you do your y prime of just that, stuck with 4x plus 3. Okay, and that's your answer. Okay, we canceled that out. We found a way to get rid of the fraction. We didn't even have to use the product or quotient rule. Okay, now looking at 12. How can we simplify 12? All I did was I got rid of the fraction. Right? Get rid of the fraction. Save yourself some time. You can pull that 3/2 out, right? 3 over 2. So this is just like 3/2. And then get rid of your 1 over x to the 5th. The same thing as x to the negative 5th. So now when you take the derivative, your y prime is just going to equal 15 negative 15/2 x minus 6. And actually getting rid of that negative, you don't want the negative exponents, so that's going to be negative 15 over 2x to the 6th. So that's going to be your final answer. But yeah, simple and easy. So think about your rules and how we can manipulate these equations to make them easier to do our little tricks. All right, so for 13, let's change this. Let's get rid of the fraction, and we can end up with a 9x to the negative 1/3. Right, we're just getting that x out of the bottom. So then when we take our derivative, y prime is going to equal to negative 3x to the negative 4th over 3. Okay, and getting rid of our negative exponent, we should end up with negative 3 over x to the 4/3. Okay, remember we always got to get rid of those negative exponents to finish our work. Moving on to 14. So what I did was I factored the top, and when you factor the top, you get x plus 2, x minus 1, and we have x minus 1 on the bottom. So look at that. Cancel them out. You get x plus 2. When you take the derivative of x plus 2, your y prime equals 1. Okay, easy one. Think about ways you can cancel out huge parts and get to places quicker, okay? 15. We have x squared plus 3x over 6. We can simplify that, kind of make it like fractions, right? Distribute that 6 on the bottom both ways. So you have 1/6 x squared plus 1/2. Excuse me. 1/2 x. So when we take our derivative, our y prime, right? Simplify it one more step. And that's your final answer. Excuse me. Whew. So we're moving on. 16, our last one. All right. So we got a little bit more going on. Got to find a way to simplify this equation a little bit more. So what we can do is we can multiply the top by 1 and we can manipulate this equation a little bit. Okay, now we're going to multiply by 1 over x plus 5. So we can get some that looks a little cleaner. 3x minus 1 over x squared plus 5x. And I say this is cleaner because now we have two clear functions that are a little bit easier to work with that we've dealt with before. So we're going to keep doing our work. All right, so we're taking the derivative now. Y prime equals x squared. Remember our high D low, low D high. Okay, all over our low times low. Okay. From here, there isn't much simplifying we can do. We can cancel some stuff out, but you're going to get your final result, your negative 3x squared plus 2x plus 5 all over x squared plus 5x squared. All right. And that's all I got for today. Remember, a great way to go through these lectures, especially if you want some practice, is to start the problem, watch me start it, try it on your own, then watch me solve it. Okay, see if